Ladies and gentlemen.
Good afternoon. Hello.
Welcome to our first lecture on electroacoustics. And so I'm glad to be with you at this time. And my name is Electroacoustics, and I'm going to have with you almost all the lecture as well as the tests on this subject in this semester. Well, let me show you some presentation. Just a moment. Yes. So today, as I told you, we have the first lecture on electroacoustics, and so let me tell you a few basic things for this course. As I told you, my name is Electroacoustics, and our other co-lecturer will be Professor Krzysztof Opieliński, but he is going to talk to you only the one lecture at the end of the course, and this lecture will be on ultrasound technology. So I'll be the lead lecture for you, and I'm responsible for all the notes. And if you have some problems with laboratory, etc., please contact me. So my name is Mauricy George Keen at pw.edu.pl, and my contact time is Tuesday from 11 to 13 in room 604 in C5 building, or online. And another contact time is Thursday, so it is today, just before our lecture from 13th to 15. And I hope that in the future, in this time on Thursday, I'll be only online as a consultation. So link for my consultation is as follows. So please remember. So I'm going to put this presentation as a PDF in a e-portal, so don't worry and don't write this link because you have to access to them. So this course it's going to, yes. Yes. Oh, okay. Just a moment, because it's some technical problem I've got in the previous semester. Just a moment. So you don't see the slides when I have you seen the another one, lecture, etc., or not? Okay. Yes. And this presentation, it can be seen, yes, or not? Nothing. Okay. One more time. Okay. And how about this one? Yeah. And at this time, you can see this presentation or not?
Yeah. But
Yeah.
we are seeing the editing page of PowerPoint.
Yes, I know, but
This we can see.
If I turn the slideshow, you don't see any changes. So
yeah.
Okay. Mm-hmm.
I think it's because you are sharing the PowerPoint program, and when you start the slides, it creates
Yes, I did, but
maybe if you share the screen, we could see it.
And how about this one? Works or not?
What if you share screen and not the program?
I use the share screen, but I don't know what happens.
But we don't see like a start menu on the bottom. So
yeah.
like the whole screen.
On my screen, I've got my presentation, and this is a share screen also. And this is some working form of the PowerPoint presentation. Have you got it or not?
No. Could you please change the slide? Maybe the second slide. Okay, we see the change now.
Okay. Okay, so I'm very sorry for these technical problems, but I try to do my best to inform you and omit these problems. Okay, so the form of the course is going to be in such a way that the first two lectures will be held in e-learning mode, as today, for example, on the Zoom platform. And how about the rest? I don't know. Maybe you prefer to have the lecture on site or not. And so, how about other lectures of Thursday? Because as I know you time schedule on Thursday you have only some lectures, and so I don't know the decision of Vice Dean, which is going to make some decisions. So I don't know, but of course I can inform you what will happen. So a few days before each lecture, you will receive an email with confirmation link to the lecture. And after each lecture, the presentation PDF, as well as some additional material, if this material exists, will be placed on the platform eportal.pwr.edu.pl. So have you got some student representative if you have, so please, this person contact me, okay, via email or okay, via email is the best form. Okay.
Okay.
Okay, so it's necessary for our cooperation. I hope good cooperation. And so the time schedule of our meetings is as follows. We have 6 meetings, and on the 7th one will be the test. So be careful, but with the date of April 13, because it is a Wednesday, but you know, some days in our university could be changed, and so there's not really actual actual day. So the classes from the Thursday will be provided on Wednesday, and so the test number 1 will be take place on Wednesday. And on the second part, it's without some surprise, and so every Thursday we can meet. And the final test will be on June 9th. And so this test will contain the knowledge of the part of material from the second part of lecture. So how about the credit requirements? 2 tests will be on the first one on April 13 and the second one on June the 9th. And I'm going to give you some details of the test via e-portal or via email or via your student representative. The condition for passing this course is obtaining a positive grades from both tests, as well as passing grade in the laboratory. I hope that the laboratory will start next week or in 2 weeks. Because as I talked with the men who are responsible for laboratory, they told me that some time shift will be for good synchronization with some news from the lecture. And rules of the test. This test will be placed at the e-platform or on site. It depends on the form which we will meet our the other terms, you know, because when we have all classes on site, so the test will be written on site. But if we have up to the end of semester via Zoom, so the test will be placed at the e-platform. So the test, each test takes 30 or 45 minutes, and I think that 25 test question will be enough for this time. And to pass the test, you must answer correctly to the minimum of 11. And each question has 4 options, and only one is correct. So it's not a multiply choice, but it's only one choice. So it's for you, it's easier to passing these tests, of course. So if you don't pass the test, I don't think so that a lot of people will be in this situation. So we'll be able to take the test 3 times in addition. And of course, I will inform you about the dates and some subsequent attempts. But the final score of the test is the score from the last attempt. For example, somebody received 4 from the test number 1, and he or she is going to improve these notes. And so the next time he or she will be writing the test, and this person obtained, for example, 3. And the last 2 2 attempts will be also with results as a 3. So the final note for the test number 1 or number 2, doesn't matter, will be the last note. So in this case, 3. So be careful to improve the notes, you know. But I think that we don't make some arguments with us. So I think that our cooperation will be very good. And so in part 1, the topics which we discuss is in basic laws, quantities and elements in acoustics in general. And so this is a subject for today. And the next week will be some mechanical and acoustic oscillations and electromechanical and electroacoustic analogies. The third one is psychoacoustics and hearing. The next will be something about speech and speech signals, and sound propagation, room acoustics, as well as noise control. And at the end of the first part will be the test. And the second part will be transducer in electroacoustics in general, so microphones in details, loudspeakers or earphones, audio amplifiers, loudspeaker systems, electroacoustic channel systems, applications of electroacoustic, I mean some quality assessment, hearing aids, as well as digital audio broadcasting. And at the end, Professor Opieliński will be talking about ultrasound technology. Bibliography for this lecture is as follows. The most important thing is a lecture and presentations. The second one is a very good book written by Jens Blauert and Ning Xiang, Acoustics for Engineers. Another one is Everest, Master Handbook of Acoustics, 4th edition. You know, it's not necessary 4th edition. If you have the first, the second, or the third, it's also very good. And some additional books or some sources, if recommended, at the end of each lecture. So, have you got some question on the rules or on the way of conditions of passing this course, or everything is clear?
I think everything is clear.
Okay, so let me tell you a few words, a few basic things on some acoustics, acoustic or electroacoustics. So, you know, the auditory system of the people is the most important communication organ. And you can notice one thing. So blind people can be educated much more easily than deaf ones. You know, auditory organ is very important for our education process as well as a human being. For example, when watching TV, some interruption of the sound is much more irritating than the interruption of the picture. And some three basic terms should be introduced to talk about acoustics or electroacoustic in general. The first one is auditory event. What's that? Auditory event is something that exists as a heard and becomes actual in the act of hearing. And it's also known as auditory object, auditory percept, or auditory sensation. About this thing, I'll be talking wider on our third meeting. Of course, this auditory sensation will be done for some sound which will be perceived by the people. And what the sound is? The sound is a mechanic vibration and or mechanic waves in elastic media, as well in the air, for example, in the solid environment, etc., etc. And this sound makes, of course, some auditory event. And to talk about some acoustics as the science of sound and its accompanying auditory events, we should divide some frequency ranges into sound categories as follows. First of all, this is audible sound, and it is from 60 hertz to 60 kilohertz, or in some other sources from 20 hertz to 20 kilohertz. And ultrasound for frequencies higher than 16 or 20 kilohertz. Infrasound, it's for frequencies lower than 16 hertz, and hypersound with frequencies higher than 1 gigahertz. Of course, our interest will be mainly in audible sound, so in this range of frequency will be interest for us. In this picture, I present you the schematic view of a transmission system. As A, so the upper part of this picture shows the general transmission signal, and B is a electroacoustic transmission system as in the meaning of receiving end. We have some receiver, and we work with some electric signals, and transducer. We convert some electric signals to the sound, and this transducer makes some sound field, and sound field is perceived as many of auditory events in by our hearing system, and so making some some acoustical sensation or psychoacoustic sensation. So our interest will be the source and some transducer to pick up the sound from the source, and some conversion, and a few words about some transmission channel, but not many words because it's a domain of telecommunications, for example. And our great stress will be on the second part of electroacoustic chain. I mean, from the receivers to via transducers, making some sound field and the perception of the sound. Let me tell you now some relevant quantities we use in acoustics. First of all, the very important thing is acoustic pressure. So the definition is that acoustic pressure is the difference between instantaneous value of pressure in medium with acoustic wave and atmospheric pressure. So when the atmospheric pressure is rather constant, or it changes slowly, so the acoustic wave changes relatively in respect to atmospheric pressure very fast, and this means that some acoustic pressure symbolizes some information delivered from the source to the receiver. Of course, relative change of medium density caused by acoustic wave, and acoustic velocity, it's a velocity of vibrating particles in the medium. So it characterizes motion of the particle, not motion of the wave, but motion in the particle in micro sense, okay. And so we use also some another quantities as displacement, particle velocity, sound pressure as an alternating pressure as caused by particle oscillation, sound intensity, which is a sound power per effective area, and it is perpendicular to the direction of energy propagation, and speed of sound, C, with unit in meter per second, and it is a propagation speed of sound wave. And as I told you, don't confuse speed of sound with particle velocity, because as I told you, the speed of sound refers to the wave, sound wave, and particle velocity refers to the velocity of some minimum particles of, for example, some vibrating structures. And of course, these quantities are periodically alternating, and they can be decomposed into some sinusoidal components, and of course they will be written in a complex form. Of course, you don't need to remember all the mentioned quantities, but you you have to make some orientation what displacement means, as well as for example velocity means. Yeah. And in acoustics we use also a few kinds of impedance. The first one is a field impedance, and this is quotient of sound pressure divided by velocity. The mechanical impedance is another kind of impedance, and means the force divided by velocity. And acoustic impedance, it means that pressure is divided by so-called volume velocity, and volume velocity with a Q letter here, and it's a product of velocity multiplied by area of radiation. And these different kinds of impedances can be converted into each other, and provided that the effective radiation area of the sound source is known. Of course, this conversion is useful for example, for calculation of efficiency of transducer mainly, and we only can talk about these impedances as a product of something, or as some phenomena which is a result, for example, summing some sources, or for example making together some sound source, etc., etc. So in further lectures we will be used these quantities. And of course, as I told you, that the very important thing is sound pressure used in acoustics, and sound pressure we can divide some to show you how broad the range of sound pressure is. We can talk about threshold of hearing, which is minimum perceived value of the sound pressure, and it is 20 micropascal. And during a normal conversation, we can talk about 100 millipascals. And the threshold of discomfort, or the threshold of pain, it's 100 pascals. So this range is very broad. So in acoustics, it's very common to use some logarithmic intervals. And we can talk about sound pressure level with the threshold of hearing at 1 kilohertz as a reference, and this sound pressure level is defined as 20 logarithms with the quotient actual sound pressure divided by reference pressure. Another one is some intensity level expressed as a 10 logarithm the quotient of actual synchronicity and divided by 1 picowatt per meter square as a reference, and sound power level also defined as 10 logarithm actual power divided by reference power, I mean 1 picowatt as the reference. So you can notice that except for sound pressure level, which have 20 as a coefficient before the logarithm. So other two we have 10 logarithm, some 10 logarithms from some ratio. But in paradox, we very often use sound pressure levels, so you can be more familiar with this with this definition. So sound pressure level is very important for us. And we can also use another unit like symbols. For example, Napier, which is based on natural logarithm, and this is often used in theory of transmission, but we in electroacoustics rather don't use this interval. So we can also use other references, but we should note that which reference is actual. For example, this one, L, this is 15 decibels with reference 10 millipascals. But you know, very common and very often used is sound pressure level, and please remember this unit here, or unit like. And very useful for you will be some differences, and you can learn by heart, or you can notice in some familiar form, because we can use very often this ratio of sound pressure. You know, 6 decibels, 10 or 20 decibels, as well as 40 decibels and 60, etc., etc., etc. So please remember, particular in this column, you know, because it will be very useful for you, and you can use it in everyday life if you work with acoustics or electroacoustics. And this picture can show you the ranges of sound pressure level, and this range corresponds to some sound source. The most louder source is a jet aircraft, and such environment, for example, a disco club, it is 100 decibels. Vacuum cleaner, the 1 meter distance, 17 decibels, 70 decibels. Conversational speech, as I told you earlier, is about 60 decibels. And the threshold of hearing 0 and rustling leaves in the distance is only 10 decibel. And this is for you as an expression of sound pressure level instead of sound pressure expressed in pascals. And so, a few words on oscillation, because general decibels and quantities means that some introduction, but oscillation is a kind of or the way which some vibrating elements makes the sound. So the oscillation is a process with attributes that are repeated regularly in time. And we can distinguish some basic elements of oscillating linear mechanic systems. This is mass, for example, the first, spring, as noted here as a B letter, and fluidic damper shown on the section C. And as you can see that F is the force, and V means some velocity actuating the mass, and in the case of spring, the velocity could change. And this is a delta of V, as well as in the case of damping. The damper should change the velocity of the particular velocity. And so we can express these quantities with some mathematical apparatus, but you know, in my opinion, this apparatus is not necessary for you to understand some facts, and so please forgive me that I omit some mathematical formula, and I use only some necessary formula to express some phenomena because of the mind, and I prefer to explain some phenomenon on the base on from physical point of view, not on the base on mathematical rules. And so when we have a mass, we have actuated force F, and it is a mass multiplied by acceleration. And so from physics theory, it means that it is equal to mass multiplied by differential of velocity in a time, or quadro differential of displacement with the time. And for sinusoidal quantities and in complex notation, we can express force as a product of omega square multiplied by mass m and displacement c. And so mechanical impedance of a mass is is shown as in this formula. So we have we have omega. So it is 2p multiplied by frequency and multiplied by the mass, value of mass. And so the mass as an element stores kinetic energy only. Another element is a spring. So spring has a compliance n, and for sinusoidal quantities, we have some equation that's f means this the difference of displacement divided by n divided by compliance, or if we use as usual in acoustics the stiffness as a opposite quantity to the compliance, we can we can express the force as a displacement multiplied by stiffness k. And the main feature of spring is that the spring stores potential energy, and mechanic impedance of spring is as follows: is 1 divided to omega and multiplied by compliance. And this is a spring. And damper or dashboard has some mechanical resistance, and this is product of multiplication of this resistance and the difference of velocity. And mechanical impedance of the damper is real, and this impedance is equal to resistance. And the dashboard or damper doesn't store energy, and it consumes it through dissipation, for example, making a heat. And let's talk a few words about acoustic elements, basic elements of acoustic systems. So the acoustic elements are formed usually by small cavities filled with some fluid, for example, gas or liquid. And to define the acoustic elements, we often use the sound pressure and sound pressure difference and the volume velocity. So this is multiplication of area and velocity varying in time. And so the basic elements are acoustic mass, commonly known as a hole in the wall. It means that this is a gap in the wall, and both sides of this wall has the same volume velocity, but with a difference in sound pressure. And acoustic spring is another one. It's a hole in the wall, but the closed hole in the wall. You know, when the air goes to this hole, it's no way to escape this one, and so it is some kind of cavity, etc. And acoustic spring means that it is volume velocity and some acoustic components in this chamber here. And if we have some hole in the wall filled by some porous material with some resistance, and we can talk about acoustic damper. So we have in analogous to the acoustic mass that the volume velocity is the same from both sides of this wall, but the sound pressure is different, and we can use this formula as shown here. And we can talk about these basic elements, and we can use it when we will talk about, for example, some transducers, etc., etc. So don't worry, some application will be presented by me during the next lectures. And so, a very important thing and very important element, which I'm going to ask you in the test, is the Helmholtz resonator. So this resonator is commonly demonstrated by blowing over the open end of a bottle to produce some musical tone, for example. Yeah. And so the mass, damping, and compliance are connected in cascade. So the total pressure results in as a sum of three pressure values in these borders. For example, at the entrance to the resonator, the start of acoustic resistance, and in the point which is a border line between this cavity and this porous material. So this Helmholtz resonator is very useful for explaining something, and this is useful construction or useful element for improving frequency response characteristic, etc., etc. So we use this resonator for construction of microphones, and so wait and we'll see how about the application of Helmholtz resonators is. String. String is a continuous one-dimensional or linear system in which its own stiffness is negligible compared to the stiffness of stretching. And this displacement of the string is transversal to the profile. And other important thing is that the displacement depends on coordinate along the string and, of course, the time. So this displacement may be the function of place of observation, and of course on the time of observation. And so string equation is as follows, and the speed of the wave in the string is expressed as a square from the quotient of force of stretching divided by linear density. And most general solution of the string is expressed as a sum of two functions. The first function is called running wave, and other function is returning wave of this string. And of course, the waves in the string are transversal waves, and the strings usually can be expressed as free vibrations of the modes. For example, the first mode is presented in this picture. You can see that we have only only one maximum, and this maximum exists at the half of the total length of the string. And the next one, the second mode, has maximum here and maximum in the meaning of module in 3/4, and the note is at the in a half of the length. And so the next modes are presented as follows. And so some very important things for string. So the number of natural frequencies is infinity, but it is an ideal string. In real solution, so in real state, the number is limited to the some number of 10 or 20, dependent on some dimension or cross section of the string, etc. And the higher natural frequencies of the string are harmonic in relation to the first one. And so it is very important thing. And the solution of the equation for each natural frequency is the continuous eigenfunction. And the points on the strings for which the displacement is 0 are called nodes. And for next natural frequency, the number of nodes increased by 1. So if we are talking about the fifth natural frequency or fifth harmonic of the string, so we can find the number of nodes is equal to 5. So if you know about string, you can play guitar, for example, or other string instruments. Of course, I joke. And let me tell you a few words about vibration of the membrane. String was an element which is in the meaning of one dimension. And my membrane is a continuous two-dimensional or surface system in which its own stiffness is negligible in comparison to the stiffness of stretching. And displacement is transversal to the surface of the membrane and depends on two coordinates, because there is a two-dimensional surface, as well as the time. And membrane is an analogous system to the string in 2 dimensions. And natural frequencies of circular membrane are presented in this table. And you can see that higher natural frequencies are not in harmonic order to the first natural frequency. So it means that membrane, as well as a plate and other structures used in electroacoustics, can vibrate with some modes which have frequencies not harmonic to to the first natural frequency. And modes of vibration of circular membrane are presented here in this picture. You can see that circular membrane can difference in this vibration not to push and pull matter, or to make some strange figures, etc., etc. So in the laboratory you can measure the beam, and the beam is also a structure which has its natural frequencies not in harmonic order. So if you measure this beam, you can notice that all frequencies measured by you aren't in a harmonic order. So I think that it's enough for today in the first lecture. And the most important things to remember is basic quantities used in acoustics. As I told you, I don't make some questions on these quantities, but I will use in the next lectures, during the next lectures. You can remember the nature of decibels or the logarithmic scale. And of course, you can note, you can know only as a preview some basic elements of mechanic and acoustic systems, because I'm going to use these systems in particular if I talk on loudspeaker and if I talk on microphones. Very important thing is a construction of Helmholtz resonator, and you have to learn this Helmholtz resonator, and you can also remember that string is a vibration, has its vibration according into the harmonic order, but membrane vibrates not necessarily in such a way that the higher components are harmonics to the first natural frequency. So that's all for today from me. Have you got some questions? If not,
Professor,
yeah.
I have a question about the.
Yeah.
Did you say in the beginning of the lecture that you will put the presentation available for us, and where it will be? Where would the presentation will be available for us?
The presentation will be put in the e-portal.
E-portal, okay.
E-portal, yes.
Okay, thank you.
So e-portal, everyone. Today, just before the lecture, I checked that all of you can attempt to have access to the e-portal. So so please download this one and try to learn.
Okay, okay, thank you.
You're welcome. So I'm going to tell you that except for the next week, which also is a lecture on some basic theoretical consideration. So I promise to you that from the third lecture, the topics will be more practical. So you will be more satisfied in comparison to today's first lecture, because you know there's some kind of theory given us some direction of meaning. Last year, when Professor Dobrutsky has the first part of this course, it used to write a lot of formula, and so this theory was based mainly on some mathematical solution of some of equations, but I realized that more important is to know the phenomena rather than solving equation, for example. It's my opinion, so maybe you don't agree with this opinion, but this lecture will be more practical than last year's, last few years when Mr. Dobrutsky has lectures from the first part. So I promise to you that from the third lecture, the topics will be more familiar to you, and will be more explained in a practical form. So if you don't have any questions, I think that that's all for today, and so see you next week. I try to make to put this presentation to ePortal just after this lecture. So thank you very much for your attention. See you.
Okay, thank you.
Goodbye.
Bye.
Thank you. Bye.
Bye.
Bye.